Okay guys, so in this video, I'm going to solve some exercises from sections 12.2, 3, 5, and 6. Hoping that as I solve them, you will have elements and good information to have as a reference to help you solve your homework assignment. So let's begin with this. In section 12.3 and 5 and 6, we learned about the four triangle theorems of congruence, right? We need to make sure that at least three elements that are sorted out in a specific way. Once I have two triangles and I can figure out the correspondence of each of its elements of their elements, then I can start working out a reasoning that will lead me eventually to know whether those two triangles are congruent or not. Okay, so I'm going to start with the couple of triangles you see here. One is against the other, and they are sharing one of the segments. And as you can see is the segment BD. I'm going to use blue to start indicating everything I do here. All right, so this is segment they share. And there is a specific property to make it more formal that will provide the reason why we say that they are sharing. Since they are sharing a segment, we know that the segments are congruent, of course. Okay, and it's called the reflexive property of segment congruence. And I'm going to use it in a moment. The thing is, we need to start working out something we call proofs so that eventually our conclusion will be what we are expected to do, which means in this case we have two triangles. We have triangle A, D, B. You go from here, then here, and then here is actually congruent to the triangle, and let's see the corresponding vertices. A is corresponding to C, so we start with C and then D because it's shared here, and B. Okay, that's what we want to prove. I need to demonstrate that. I need to use supporting arguments, and this is going to be helpful for you guys because everything I say needs to be supported with something, right? Which means that we are going to do something like this. I'm going to say something, a statement, not necessarily an opinion. A statement is something that needs to have a supporting information, and that's what we're going to do in order to build upon each of the arguments here to eventually prove. This is what we need to prove. We need to prove that these two triangles are congruent. That's what I need to eventually get. That's my goal. Okay. So from our, I'm going to delete some of these to erase them because we need some more. Okay, look at that. I know that based on what we've learned before, these two marks indicate that segment AD and CD are congruent. Okay, and it was part of the begin. It was there since the beginning, so I can start with this information as something we call a given. So I can state that. I can say that AD and CD are congruent because it's a given. That's the reason. Okay, it wasn't the picture. It was an initial condition. Also, if you notice that's my first statement here, and I am already saying that there is a segment, a congruent segment, a pair of congruent segments. Now, I can also say this. If you notice, there is a 90-degree angle here. Angle, you can say BDC because I start from here, then go down here, and then make it to C. And as you can see, D is the vertex of that angle. Angle BDC, we are absolutely sure, and I should write it like this. The measure of BDC is 90 degrees because of this square right here. Okay, that's a given. Okay, that was part of the picture. So I can also say something. Because of it being 90 degrees, and if you take into account this segment from A to C, you now have something like this. This is A, this is C, and you have D right here, and then there's the angle. Then we know that by supplementary angle theorem, this other angle, which is going to be the angle BDA, BDA is also going to be 90 degrees. So now I'm going to make it a little bit more formal, right? I can say something like this. I can say that the measure of BDC is 90 degrees, and it was also a given. But still, I haven't shown anything yet. But what I can do is that I can say that the measure of BDA is also 90 degrees because it's the supplement of the angle BDC. All right. I know this is a little bit more informal, but we are connecting this to this. Okay. They are a linear pair. It means that BDC and BDA are a linear pair just because what I explained here. Okay. And because of that, if BDC is 90, then BDA is also 90. Again, I'm doing this in a kind of informal way, so I am making sure that a pair of angles is congruent. Now, finally, I want to make sure that you guys take a look at this. Here we have BD. Oh, sorry. And as I was telling you earlier, this is a segment both triangles have in common. And because of a property I'm about to write here, let me extend this line and I can say that segment BD, let's keep doing the blue, segment BD is congruent to segment BD. It's repeated, right? And why is that? Because of the reflective property of, okay, I'm just going to, sorry, reflexive property. I'm made a mistake here, okay? So because of the reflexive property, okay, of segment congruence, and again, because as you can see, they have this segment in common, then those segments are basically the same. It's the same thing, okay? Can you see how I made sure that I wrote a pair of segments, a pair of angles, and another pair of segments? And remember, this angle is in between the segments, the congruent segments, because I'm going to indicate in red. Here we go with this segment, and the angle is connecting both of them. Because of that, I can finally state what we wanted to prove, this, okay? Which means triangle ABD, or sorry, ADB. We can say that. So triangle ADB and triangle CDB are congruent because of the SAS theorem. And that's the final statement because I just proved that. Okay? But it was because I previously logically connected some statements that led me to these three things being true, side, angle, side, and then I can state the last one, which is the conclusion I wanted to show. All right? That's for 12.3, okay? I'm going to keep going on. This is going to be a long video, so if you want to pause it and rewind it, feel free to do it. I'm just going to continue with other exercise 12.2, where we were just dealing with correspondence, okay? And I should have done it in our previous exercise, but I'm going to do it in exercises 12.5 and 12.6. So here's the thing. If you look at this this pair of triangles, okay, you might see that you somehow, and because of what we learned in chapter 11, let's take a look at triangle TUV. If you perform a couple of transformations, I could eventually take it down here, rotating it and maybe translating somehow to show you this. And I'm going to use red this time. If you rotate it, maybe almost 180 degrees, and then you translate it, you will eventually get something like this. Okay. Sorry, this is terrible, so I'm going to draw a new one. It's going to be something like this, okay? But this time, as you can see, when you rotate it that way and translate it that way, now make sure that you understand that U goes here, T goes here, and V goes here. Sorry. That means that UV is located right here, and this angle is right here. We have a 54 right here, and we have an 80 right here. Okay? So now, here's the thing. What we need to know is to figure out in this specific exercise, we need to find out the measure of angle 1. It's right here, located at vertex X. Once you do the transformation and you understand, we usually do it in our minds, but this time I'm doing it in drawing, as you can see, and I wrote it and I drew it. You can see the correspondence between the segments XV and UV, and they happen to be congruent. Now, the correspondence between angle X and angle U. All right, they are corresponding. So what I want to find out is the measure of X. I have nothing or no information whatsoever in terms of measures of segments or angles in the triangle XVW. But I can use triangle UVT to figure it out. As you can see, this segment and this segment is the same. And now look at that. This measures 54 and 80. And I know that if I add 54 and 80, and I'm going to use a letter, let's use alpha here. It's a Greek letter, if you didn't know, plus alpha. Remember, the sum of these three interior angles is always what? 180. I know you know it. And I'm just going to solve for alpha, okay? This is going to be 134 plus alpha. That equals 180. And then alpha, right, is going to be 46 degrees. So if alpha is 46 degrees, because of the correspondence and because of this mark, guys, remember, this mark, I know that these two angles are the same. So I can definitely say that the measure of angle 1 is also 46 degrees. And I'm done with this exercise. Feel free to rewind or pause it as needed to make sure you understand every single thing we did here. Now, let's move on to 12.5, and we're going to deal with the theorem SSS this time. Givens, remember, information we are provided with and we can easily use as our reasons, okay? Remember the what and the why. So if you look at this diagram, B is the midpoint of CD. Let's understand that. So you have CD right here, CD. And B happens to be the midpoint located right here. That means something, guys. It means that BD and CB happen to be congruent. You know, if you cut something in half, you have two congruent parts. Like 10 divided, a segment whose length is 10, if you get the midpoint, the distance between, in this case, CB and BD are the same. All right, we already know that. So I can say, for example, starting from here. So I can say B is the midpoint. Let's just wait for it to save my image. So I'm going to write B is the midpoint of CD. Omar, why do you say that? Well, I say it because it's a given. End of story. But because of this, I can say that CB and BD are congruent. Why do you say that? Well, because B is the midpoint of CD, right? Can you see how we are connecting those links? It's some sort of chain here, okay? Right? Okay, this is helping me a lot because this is now one of the segments that are congruent. Now, take a look at something. Because of what you see from the picture, right? Can you see segment AB and segment EB happen to be congruent because the initial conditions are telling you that. So it's also a given. So I can say that segment AB and segment EB are congruent. Why do you say that, Omar? Well, this is a given, okay? And with this, I have the second pair of segments being congruent. I'm close to it because I just need to prove that the third one is also congruent. Let's see how it goes, or let's see if I need to do it any other way. Well, you know what? It doesn't, I mean, in this case, it's not even SSS. It's just hypotenuse and one of the lanes. This is one of the theorems that I do not necessarily teach a lot because it's maybe mm, for other moments, okay. But now with this, I'm done because, and then you will see it in the book and you'll see it in your exercises. Here's the thing: I don't need this as because I already proved. If you see, these two triangles are right triangles, okay, which means that the longest length is the hypotenuse. So this is AB is the hypotenuse, and I just needed to prove that there were other lanes that were congruent, and then because of this, now we're done because it's a pair of right triangles, and that's it. I wanted to focus on one more, right? Because I want to make sure that we use one of these, ASA or AAS. Let's take a look at AC. Sorry, let's look at these two triangles. Triangle ACB and triangle ACD. Or we need to be consistent in the way that we label them, as long as it is. You can label them any way you want as long as you are consistent with the correspondence. Okay, A is corresponding to A, C is corresponding to C, and B is corresponding to D, right? So you see AC, and then BD, or you see AB, AD, and then C. Either way is fine. Okay. All right. What do you notice? All right. Let's first take a look at the givens. The given AC, the segment AC here in the middle, bisects. Remember that bisecting means that you cut in half. In this case, it is splitting or bisecting the angle DAB and DCB. Okay, so look, this segment AC is bisecting two different angles, right? Let's see which angles. Oh, sorry, my bad. Okay, here we go. The first angle it bisects is DAB. DAB is this angle. Let me show you. DAB, it means this angle right here is going to be bisected, which means that now we can do this. We can say that this angle and this other angle are congruent, right? Just imagine that DAB, the complete one, was 60, so this should be 30 and 30. Okay? We're not dealing with numbers here. We're just dealing with those elements that help me understand what happens each time, in this case with the angles, or in other cases with the segments. So we can also take a look at this bisection. That the same segment is bisecting DCB. DCB. This angle right here, this big angle, obtuse angle, is bisected, which means that this segment right here, my bad, this segment, okay, let's just delete this, and then here's what we're going to do. In green, this segment right here, and I'm going to double the arc, is congruent to this segment right here. Got it? So what do we have now? Let's begin with the proof. We can say that AC bisects DAB and DCB. Reason, Omar? Well, it's a given. Okay? And because of that, I can state the following. Angle DAC is congruent to angle BAC. When I look at which ones I am talking about, I'm going to do it in red. Okay, look at that. Here to right. DAC is this angle, and BAC is this other angle. They happen to be the same, or we say in geometry, they are congruent. Why is that? Because AC bisects, in this case, DAB. And I can say the same thing about what? About angle BCA and angle DCA. I'm showing you here in other color. BCA is this one right here, and DCA is this angle right here. They are congruent because of the same reason, because AC bisects angle BCD. Okay, so I have angle and angle. Finally, I need to find a side. Is this going to be ASA or AAS? Well, the only thing I can do now before I conclude my exercise is this. If you look at the triangles, they share a segment. They have a segment in common. What segment is it? It's AC. So I can say that AC and AC are congruent by, remember, when they have a segment in common, I can say that those segments are the same, obviously, by reflexive property. So I can say that this segment AC right here is congruent to segment AC. So this segment AC is in the middle of the congruent angles. So my conclusion is that we're dealing with an ASA theorem here to finally say that triangle, just like this, because that's what we needed to prove. Triangle ABC and triangle ADC are congruent. Why, Omar? Because of the ASA theorem. And I'm done. Okay, guys, that's it. Make sure if you have questions, just ask me, rewind your video, okay, or get help from someone else as well in any of your classmates. Okay, that's all, guys.